All right, so yesterday we started planning out where the coordinates on our board are going to be, and let's just kind of fill in some more of these here. So here we have the point 170.10, that's this endpoint, okay? This is the endpoint 174.90, okay? Over here we said 170 plus 160 gets us to 330. We haven't moved up or down, so our y-coordinate should still be 10 there, okay? If we go straight down, then we're not moving left or right, so our x-coordinate here should still be 330. And if we are moving from here to here, then we're not moving up or down, so our y-coordinate should still be 490. Hopefully that's all making a lot of sense to you. So let's look at this point here. This point we said is at x equals 10. Okay, the y value is going to be 10 for the buffer plus 160, so you should have 170 here. And then what you should notice is that maybe we have like kind of a mirror image. So 170.10 became 10.170. 330.10 is going to be over here at 10.330. Same thing over here. So 330.490 down here. This one over here is going to be x equals 490, y equals 330. Now that's not, you know, like a technical way of thinking about how where this point comes from, but if you thought about it a different way, that's fine. So same idea over here. This is going to be 490 in terms of x, and then 170 in terms of y. Okay, so the other thing I asked you guys to try to figure out was where are these center points. Okay, and so did anybody find a center point there? Yeah, what'd you come up with? Okay, so you came up with 90-90. How did you think about that being 90-90? All right, so he said basically the buffer is 10 pixels, so this point here at kind of the top left of the board is going to be 10-10. And then he said we know that each of these squares is 160 wide and 160 in height, and if we divide 160 by 2, we get that equals 80. So if I start at 10 and add 80, add half, and then start at 10 in terms of y and add 80, I'm going to get to 90-90. All right? Anybody come up with the coordinates for this point? Yeah. Okay, so good. 250, 90. And how did you come up with the 250 there? So you said that basically from here to here is like the same size as a square, so that's also going to be 160. So if we started at 90 and added 160, we'd get to 250. Okay? Another way to think about it is just like James was saying, if this is 160 from here to here, then it's 80 from here to there. And if I start at 170 and add 80, I get to 250 that way as well. Okay? So hopefully you can kind of figure out for yourself that this point is at 410.90. Okay? And so for example, like this point is 250, right? This point here is going to be 410, and maybe you can figure out the rest of those on your own. Okay, so we'll come back to this in a second here. But let's go ahead and kind of move on down the sheet. So we just figured out what are the coordinates of the centers for some of those centers. Every square area that is defined in a tic-tac-toe game is either going to have an X mark or an O mark in it. The area that the X mark or O mark will go into will be a what by what pixel square. So what we're thinking of, that each of those small squares is 160 by 160. So in other words, this is 160, this is 160. Okay? And if we drew an X in here, maybe we would leave a little buffer area, okay, from here to here, and a little buffer area from here to here. It might look kind of weird if we did it like all the way across to the corners. So if we drew that X like that, that's that's how that might look. And if we went ahead and said like, well, we've been using a 10 pixel buffer, let's go ahead and use a 10 pixel buffer there as well. So then there's a little buffer area here and here, and so this width of the X is going to be 160 minus 20, which equals 140. Okay? And we could say that's the same thing for the height. Okay? So we said over here that the width and height of the shape is going to be 140 pixels. Sorry, that's a little bit off the screen there. Okay? So we're basically leaving a 10 pixel buffer for that. Okay, we're going to come back to this part of the sheet, but let's just turn it over. Okay, so we actually already answered this question when we did our UML diagram. Okay, we talked about what the XMark and OMark must keep track of as state variables. What did we say that they would need to do in terms of like characteristics, or maybe we called it properties? What did we say that the marks have to keep track of? Yeah, their location, right? And how did we break the location down even further? X and Y, okay? So what we're trying to do here is say, okay, so this XMark or OMark is going to have int variables X and Y. And those are going to keep track of the location of the shape of the mark. Okay? And if we flip it back over to this side, remember that when we talked about this, we said, well, one of the guidelines for the project was that we wanted that thing centered. So kind of like what we're drawing here, okay? And so what we're saying is that this point, sort of the center of the X, is going to be represented by X and Y. Does that make sense for everybody? That's what that X and Y are going to represent inside of our class, is that the coordinate of that point right there. Okay? Flipping it back over. When a player clicks an area in the game, an O should appear when centered in that area. So we're going to write a constructor that will assign the position of the O. And this is kind of new for you guys, so we're going to go ahead and do this together. So remember that we're going to call this thing OMark. So the constructor will also be called OMark. All right, and so it's going to be public OMark. And then we have to define the parameter variables that the OMark needs in order to basically give X and Y their value. So those would be int the X, int the Y, and then inside of the OMark constructor, what we would do is we would say X equals the X. Okay, so you're going to give some value to the X here, okay, and that value is going to be assigned to X, which is the value that we've declared up here. Okay, and we're going to do the same thing for Y. So Y equals the Y. Okay, so that's our constructor. And like I said, I'm kind of leading you through it because it's kind of new for you guys. This is our first project like this. All right. What's next? Well, we'd like to be able to create the draw method. So what I'm going to do is I'm going to flip it back over. We're going to talk about how would we draw our X mark. Okay. So we're going to flip it back over to this guy. So this is going to be a challenge for you guys, okay? Or it should be, okay? Some people take to this real quickly. Some people kind of struggle with it, okay? So I don't know which kind of person you are for sure, but let's think about what we're doing. What we want to do is we want to come up with a general like kind of formula or general algorithm, okay, for creating an X, and we know that the X can be drawn like pretty much wherever, okay? So what are some steps that we can do for writing an algorithm? Okay, so we want to write a general algorithm. So the first thing that we're going to do is we're going to look at examples. And if we look at enough examples, hopefully what we'll see is we'll start recognizing patterns. Okay, so this third step is kind of the most I don't know, ambiguous thing or whatever. So basically what we want to do here is we want to start abstracting. We've talked about that word before. So we kind of want to abstract a solution. We want to be able to take these patterns that we're recognizing and put them in kind of mathematical terms, or put them in steps that we can always follow to get to the right solution. And so the fourth step is going to be that we're going to define those patterns using either an algorithm or like a math expression. Okay? So we're going to define a pattern using either concrete steps or a math expression. Okay? So what we're trying to do is figure out how are we going to draw an X. Okay? And the only thing we know about X right now is that it has an X and a Y position, and that its width and height are both equal to 140. Okay? So let's look at a more concrete example, because that's step one, right? We're going to look at some examples. Okay? So what we want to know is if this box has this X in it, right? And we know that this point is our center point, and let's say that that's at 250, 250. Okay? In order to draw this line, this X part of the line, I got to know what this coordinates, that point's coordinates are, and that point's coordinates are. Does that make sense? All right. So what we want to figure out then is, let's just start real simple here, because we want to know x, y down here. Let's just start real simple. What is this X coordinate going to be? 110? 10? Okay, so let's look at the bigger picture here. Okay, so what we just described is, what if I want to draw an X in this box? Okay, what are the coordinates? What is the X coordinate of that point right there? Yeah, what do you think? Yeah. Okay, so why do you think it's going to be 180, 180? Good, great. So what we just said was that this point is at 170, 170. Okay, so we know that's 170. We know this is y equals 170. So this point's at 170, 170. Okay. So if this has a 10 pixel buffer again, then this is at 180, 180. Really good. Okay. And what we want to know basically is, how am I going to get from 250 to 180? What am I doing there? So if I started at 250 and I go to 180, that means that I've subtracted 70. Okay, good. All right, let's look at another example. Let's say that I'm trying to draw an X inside of this box. Okay, so I'm going to draw this x. Okay, what are the coordinates of that point? So my center point is 410, 410. What are the coordinates of that point right there? Where did you come up with 340, 340? Yeah, absolutely. So this x coordinate is 330. I'm going to slide over 10. So this should be 340. This y coordinate is 330. Slide down 10. This y coordinate is 340. Okay? So again, let's compare 410, because that's the point that I'm going to know, right? If I'm in x. Okay? The x object is going to know the coordinate 410. Okay? How do I get from 410 to 340? What'd you say? Take away 70. Okay? So what we've just done is we've done a couple examples, right? So let's go back to this writing an algorithm. We just looked at a couple examples. We said if this is 250, right, then we're going to subtract 70 from that and we're going to get 180. And that 180 came from 250 minus 70. Okay? That's not the way you originally figured it out, right? But then we kind of saw that there was a pattern there. Okay? We said if this is 410, that it becomes 340 up here. And again, we said, well, 410 minus 70 gives me the 340. So are you starting to recognize a pattern? Yeah. What's that pattern? Subtract 70, okay? So this is, now you've abstracted a solution. Now we can define this pattern by writing a math expression. So if I know that this is x, then this x coordinate is going to be what? So we want to write this in terms of x. What am I doing to my x? I'm taking 250, and what am I doing to it? Subtracting 70. If this is 410, I'm going to take 410, and I'm going to subtract 70. If this is x, I'm going to take x, and I'm going to subtract 70. Okay? So let's leave the y for now. Just leave that blank. Let's think about this coordinate down here. Okay, how am I going to get to that x coordinate if I start here at x? Say it again. We're going to add 70. Very good. Okay, so we're going to say x. This is x plus 70. Okay? So let's go back and think about y now. If this is my y value, right, and I'm starting here at y, how am I going to go up to this y coordinate up here? What am I going to do to y? Take away 70 again, okay? So back to this example that we had up here. Remember, you said if we're at 250, 250, then this point is 180, 180. So now we're taking away 70 to get to that y coordinate, which is kind of weird, but remember that y coordinates are kind of flipped in computer graphics. It's not like math. Okay? So it's kind of flipped. Alright? So this is going to be y minus 70. Okay? What's this going to be for y? Alright, good. So this is going to be y plus 70. Alright? And then we still want to figure out what these points are, so let's figure out the coordinates of that. What is the x coordinate of this point going to be? X minus 70, good. And then y plus 70, really good. Okay, and then this point right here, we're kind of getting a little bit jumbled up here, but that point is going to be what? From x, what am I doing? Am I adding or am I subtracting? Adding 70. And for y, from y I'm going up, so what is that doing? It's really subtracting 70. Okay? So what we've just done is we've said if you know x and y, then you can draw the line from x minus 70, y minus 70, down to x plus 70, y plus 70. Okay? And then you can draw this line using these relative coordinates. So these are relative to x. They depend on x and y. Okay? So again, look at examples, see if you recognize patterns, do some thinking. That's basically what abstract a solution means, right? And then define that as a math expression. Let's flip the page over. Okay, so I've given you what your XMark class should look like. All right, and right now I want you to just ignore the this dot. So we can scratch all those out. Okay, we don't really need that for our solution, but I want you to notice that this draw method is based off of the stuff that we just talked about. Okay, so we said for this I decided I wanted a red X. I'm going to draw a line from x minus 70, y minus 70 to x plus 70, y plus 70. Do those coordinates make more sense now? Okay, so we're saying an XMark has an int x and y. It's two ints x and y. When we construct an XMark, we send it the x and the y, and those get assigned to these. When we draw an XMark, we use the position x and y to make these relative points x minus 70, y minus 70, x plus 70, y plus 70, etc. Okay, so now what you guys are going to do is you're going to do the same process and try to think about how are we going to draw my O in there. Okay, so we just talked about X, now you guys are going to try to figure out how to draw O.